So in this lesson, we're going to position our outlines we generated in the previous lesson with our user object to the 4 footprints. And I'm going to continue with the previous definition we left off. And let's move some parts of the definition to the top, the parts we won't be needing, which is the dimensions part. So let's move it here to the top. Also our surrounding context, we also won't be needing it right now, it's for later. And in the bottom, our range finder, we also won't be needing that one. So let's position it here, outside of the canvas. What we are going to use is the plot outlines. And let's move the outline generator a little bit to the right, because we'll be using it when we're advancing a little bit more in the definition. So let's turn on our plot outlines. Now first we need to generate a point in those 4 outlines, which will function as a base pivot point for our footprints, let's say. Now the way we're going to do that is by scaling these 4 plot lines using the scale component. And we also need to get the center, and we can simply use an area component for that. Now the factor, let's use a very small number. So let's insert a number slider and let's set it to, let's say 0.01. Nice. So what we're going to do now is to loft the inner with the outer polyline. So we get a surface. The only thing is that that surface will consist of multiple surfaces, resulting in a poly surface. But in the end, we want to have just one surface, let's say. So there's a neat trick to do this, and that's by rounding off the corners using the fillet component. So we need to fillet both polylines, and we can use a very small radius for that as well. So let's insert a number slider. Let's set it to 0.05. Now by rounding these corners and after that lofting them together, the result will be a surface, as you will see in a second. Don't forget to graph these inputs, so both of them have their own branch. Nice. So now we have 4 surfaces, and to quickly show you, let's say if you wouldn't have rounded the corners, let's say I set the radius to 0, you see that these are not surfaces but poly surfaces. If I insert a panel after this one, or a B-rep. But if I set the radius to 0.05, you'll find that now they're an untrimmed surface, and that's exactly what we want. Because the next step will be to use the evaluate surface component. And let me reparameterize. So the domain is from 0 to 1 in the UV direction. So let me insert a point component just to show you quickly what we're going to do. Points located under the vector tab. So we need also 2 sliders for the U and the V direction. Nice. So now we can control a point that will reach basically everywhere on the plot outline. The first U slider will make it go out, and the other slider will make it go around, let's say. So it's kind of a trick or a hack to make sure that we can we'll be able to position our footprint anywhere on the plot. Of course, a lot of positions will not make sense, especially at the border. That would mean that the footprint will go outside of the plot outlines, let's say. But we'll deal with that a little later on. And also, as you can see, I'm controlling all 4 with only 2 sliders. So we'd have to reorganize this a little bit. So let me delete these two sliders because we're going to use one of Galapagos gene pool sliders. And they're located under the Params tab, Utility, and all the way down it says Gene Pool. Now these are really nice because they already come with a lot of sliders because Galapagos already assumes that you're going to work with various sliders. So let's double click on this gene pool and let's set it to 4 because we have 4 plot outlines, so we need 4 genes. The decimals to 2, that's fine. We don't need that much accuracy. And the maximum is to 1. So that's for the U, so we need to copy it one more time for the V. Nice. So the only thing now is that we need to graph this input, obviously. So now if I move, let's say the first slider, you see that only one point moves and not all 4 of them, because now I can control them individually, as you can see here. So this one is the second one, U, and this is the V for the second one. Great. So now we can connect our 4 points to the outlines. And so we can delete the base point. And we can also delete our 4 input sliders, because we're going to use the gene pool as well for those 4. The aspect ratio, the trapezium, and the rotation. So let me delete those 4. Move this a little bit closer. So let's connect our 4 points. And let's copy one of the gene pools over, like this. Now for these, we actually want some accuracy. So let's double click on them and let's set the decimals to 5. And it's already set from 0 to 1, and that's exactly what we need. Because the aspect ratio, the trapezium, and the rotation, they also go from 0 to 1. So let's copy this component over 4 more times. Now the cutoff bottom and the cutoff top and the max degree, they don't need any sliders because those are going to be fixed. Those numbers are not going to be changing during the simulation. And also the area. So let's see the result by turning on the curve. The footprints are quite large for the plot outlines. Let's decrease the square meters a little bit. Let's set it to 1000 for now. And also let's set the minimum to 16, so a minimum depth of 16, and I think 30 is fine. Also 60 for the degrees is also fine. So now we can see if it works, so we can move the individual footprints around. And also we can individually manipulate them, rotate them, skew them, and also change their aspect ratio. So that's great. There's just one thing remaining, and as you can see, most of the time they stick out of their plot outline, so we need to prune them. And there's a nice component under the Intersect tab, if I'm not mistaken, and it's under Shape, and it's called Region Intersect. So it requires 2 inputs, and as the icon already indicates, it cuts off a shape using another shape. So for the A input, we need the original plot outlines. So let me insert a curve and link them all the way from the beginning. So those are the original plot outline. And let's graph them so they all have their individual branch. Because these already have their individual branch, so that's nice. So the plot outlines go in the A. And the footprints go in the B. Now if I turn them off, you see that right now the result, the R output from the region intersect, those are the pruned footprints. So no matter what I do No matter how I move them around, they will always stay within their plot because they get cut off, let's say. That will result in footprints that have lower square meters than initially stated, like our 1000. We'll deal with that in the coming lessons, how we're going to still make sure that the footprint will have around 1000 square meters. Great, so in the next lesson we'll extrude these 4 footprints so they have some mass, and after that we'll start by dividing the facade in an equally spaced grid, and from those grid points we're going to emit the view rays, and those view rays in the end will define our view quality. Really plainly said, the longer the view is, the longer the view ray is, the better the view quality. That will define, in the end, a big part of the fitness result for Galapagos. So thank you so much for watching, and I'll see you in the next lesson.